Okay, you're welcome back. We're asked to list the elements of 7 in U20. U20, you know, is about multiplication, and every group of multiplication we have to think about numbers that are relatively prime to the particular number in the group, like this. So U20, what are the elements of U20 actually? The elements of U20 are all those elements which are relatively prime to 20. And so 1 is part, 2 is not part, 3 is part, 4 is not part, 5 is not part, 6 is not part, 7 is part, 8 is not part, 9 is part, 10 is not part, 11 is part, 12 is not part, 13 is part, 14 is not part, 15 is not part, 16 is not part, 17 is part, 18 is not part, 19 is part. And so that is all the elements of U20. Now we want to find the elements of this 7. How do we do that? Well, the first element obviously is 7, because 7 power 1 modulo 20, modulo 20 is 7 itself. If we take 7 power 2, that's 49 modulo 20, that gives us 9. So the second element is 9. Now 7 times this 9, that is 63 modulo 20, that gives us 3. 7 times 3, that's 21 modulo 20, that is 1. And so since we have got 1, we end here because the identity element here is 1. The group itself, the identity element is 1, because all the elements in the group, if I multiply them by 1, I'm going to get the element itself. And so once you are operating or you are finding the elements of a subgroup and you get the identity element, that is all the elements. You can't go any further than that, because if you continue, you just be generating your own things. And so these are all the elements of the element 7 in U20. Of course, all this we generated them based on modulo 20. That is all. Now we look at the question 12. If Zn is a group where n is greater than 2, does it has an odd or even number of generators? Well, we don't know. We have to check and see. So they are saying that the element Z is greater than 2. So it means they are talking about Z3, Z4, Z5, going up to Zn. So we don't know. Well, Z3, what are the elements of Z3? The elements of Z3 are 0, 1, 2, that is all. And what will be the generators? Well, the generators are all the elements that are relatively prime to this number 3 here. And so 1 is part and 2 is part. So we have two number of generators. Now, what are the elements here? We have 0, 1, 2, 3. Now, what are the generators here? Well, 1, 3 are the generators of Z4. So they are just 2 generators. Now, if we come to 5, that's 0, 1, 2, 3, 4. Let's look for the generators of 5. So 1 is a generator, 2 is a generator, 3 is a generator, and 4 is a generator. So we have 4 elements actually. So if we look at the trend, what is showing is that we have even number, even number, even number. And so it means that if n is greater than 2, then we can conclude then they are even number of generators. Even, that's the most important thing for you to know. Okay, so that is all for that one. Okay, so we look at this question again. That's question 13 of our tutorial set. We have 1 2 2 1 3 5 4 3 5 6 6 4. This is actually 4, not 7. Take note. So so we start our movement. We try to see how we are going to move. So 1 goes to 2, goes back to 1. So our circle is 1 2, so which is disjoint. So we have 3 goes to 5, 5 goes to 6, 6 goes back to 4, 4 goes back to 3. So we have 3 5 6 4. Good. So we have a disjoint circle for the permutation, and so we are asked to find the order. Well, the order is the LCM of the lengths. So the length of this is 2 and the length of this is 4, and so the order is just equals to the LCM, that is 4. That's all. So the order is the LCM of the two. Okay, we don't need to permute it until we are able to get the identity element. If we do that, we can only do that 4 times until we get that, but that will be very lengthy. So don't try that. Now we're asked to find the inverse of this particular permutation in S4. Well, since they say it's in S4, then that will mean that we have 1 2 3 4, and now it's like 3 is fixed, so 3 is fixed. So and then 1 goes to 4, so 1 goes to 4, and then yeah, 1 goes to 4, and 4 goes to 2. Yeah, 4 goes to 2, 2 goes to 1. So we have it like this. And now we're asked to find the inverse. We're asked to find the inverse of this. Well, that is simple. I'm going to repeat 1 2 3 4, and I'll cut off this part and rearrange. So that will be 4 1 1 2 3 3 2 4. Rearranging, I have 1 2, this one, I have 2 4 2 4 3 3 3 3 and 4 1 4 1. Now writing it as a circle, that will be 1 goes to 2, 2 goes to 4, 4 goes to 1. So 1 2 4, like this. So that is the inverse. So the inverse of 142 is 124. 124. That is the answer that we are looking for. Okay. Now we go to question 15. They are saying that Dn is the dihedral group K is of order n minus 1 and a subgroup of D4. How many cosets of K in Dn can be formed? Well, that is let's see, that is simple. So that is simple, and so we know that the order of Dn, the order of Dn is just equals to 2n, and so the order of the subgroup K is n minus 1. N minus 1 is the order of the subgroup K, but we know that by Lagrange, the order of a group over the order of the subgroup is the number of cosets. So coset equals to order of group over order of subgroup. So that's just 2n over n minus 1. And so this is the answer they are looking for. So we end here and we continue with our last question on this set of tutorial set.